The prevailing memory of the Second World War's naval conflict is often dominated by the image of the German U-boat. We see it as the silent hunter, the apex predator of the deep, the grey wolf that brought the Allied war effort to the very brink of starvation and collapse. This is the narrative of German technological prowess and tactical genius, a story many of us have come to accept as historical canon. But what if the most decisive chapter of this story, the moment an entire strategy was shattered and an empire's naval arm was broken, was not about one ship sinking another? What if it was about a revolutionary system, a network of technology and industrial power so overwhelming that it turned the U-boat's greatest sanctuary, the vast and empty Atlantic Ocean, into an inescapable, electronically monitored killing field? This was not merely a battle of torpedoes and depth charges. It was a war fought with invisible radio waves, mass-produced escort carriers, and long-range aircraft that could appear from the blackness of a storm-tossed night. A feat German U-boat command had personally assured its captains was a physical and technological impossibility. They were catastrophically mistaken. And in the spring of 1943, during a single month that would forever be known as Black May, that colossal miscalculation would seal the fate of the WWII. Today, we will expose the full story of how that happened. And if you find value in these detailed explorations of the turning points that shaped our world, taking a moment to support our channel by subscribing allows us to continue bringing these vital histories to light. It is a simple gesture that ensures these stories of innovation and sacrifice are preserved for future generations. Picture this. It is the dead of night in the mid-Atlantic gap. For the crew of a German Type 7 U-boat, this is their kingdom. This stretch of ocean, beyond the range of land-based Allied aircraft, is their prime hunting ground. They surface under the cover of darkness, charging their batteries, gulping in fresh air, feeling a degree of safety that is impossible anywhere else on the planet. Their duty is unambiguous. Sever Britain's lifeline, sink the merchant ships, and starve the island nation into submission. As the U-boat commander scans the horizon from the conning tower, he sees only the endless black waves. Suddenly, a sound. Not a ship's engine, but the drone of aircraft motors. It is impossible. They are hundreds of miles from any known Allied airbase. Then, out of the low, thick clouds, a monstrous shape descends. A 4-engine bomber. And from its wing, a blindingly brilliant light erupts, turning the pitch-black night into artificial day. For the U-boat crew, this was the equivalent of a spectre materializing in a locked room. This was not a random encounter. It was a targeted, precise attack from an enemy that should not have been there. It was a consolidated B-24 Liberator, a very long-range patrol bomber equipped with something the Germans did not yet fully comprehend: centimetric radar. The psychological impact of that moment was profound and irreversible. In an instant, the strategic calculus of the entire Battle of the Atlantic had been fundamentally rewritten. The ocean, once a vast cloak of invisibility, had become a transparent fishbowl. The wolf pack was no longer the hunter, it was the hunted. The evidence was irrefutable, written in the fiery explosions of U-boats caught on the surface where they once thought they were safest. Captain Lieutenant Peter Erich Kramer, a decorated U-boat commander and survivor of multiple sinkings, articulated the sheer terror and disbelief that gripped the WWII. He recounted, "We were told that surfacing at night, far from shore, was our shield. We believed the ocean's vastness was our ally. When the first reports came in of planes appearing out of nowhere in total darkness, Command thought they were exaggerations. The panicked reports of broken crews. Then it happened to us. To see a plane in such conditions. It was not a battle, it was an execution. Our commanders had promised us that the mid-Atlantic was a sanctuary, yet there they were, flying as if the night sky belonged to them. In that moment, I knew our war, the one we had been winning, was over. That sense of absolute dread was not merely rooted in surprise. It was rooted in the realization that they were facing a fundamentally new kind of enemy. Because while the German sailors were manning what was arguably the world's most effective submarine, the Type 7C, they were about to receive a terminal lesson in the difference between a superb weapon and an integrated multi-layered weapon system. On paper, the Type 7 U-boat was a masterpiece of lethal efficiency. It was a relatively small, agile submersible capable of launching deadly salvos of G7E torpedoes. In the hands of an experienced commander, it could stalk a convoy for days, sinking tens of thousands of tons of shipping without ever being definitively located. It was the instrument that had given rise to the great tonnage aces like Otto Kretschmer and Günther Prien. So why was the sudden appearance of a lone airplane so utterly terrifying? Because the story of this naval war is not just about a submarine versus a ship. It's the story of two divergent technological paths, two industrial philosophies, and the unbridgeable chasm in scientific and production capacity that had opened between them. The key to the Allies' seemingly magical ability to see in the dark was a piece of technology born from pure scientific necessity: high-frequency, short-wavelength radar, often called centimetric radar. The driving force behind this revolution was a small but brilliant British invention: the cavity magnetron. While early Allied radar systems were useful, they operated on longer wavelengths, which were too crude to detect an object as small as a U-boat's conning tower amidst the clutter of a rough sea. The German Navy knew this and had developed receivers, the METOX, that could detect these long-wave radar emissions, giving them ample warning to dive. The cavity magnetron changed everything. It was a device capable of generating powerful microwave frequency radio waves, with wavelengths measured in mere centimeters. To put it in perspective, it was like the difference between trying to read a book with a floodlight and reading it with a focused laser beam. This new high-resolution radar could paint a crystal-clear picture of a surfaced U-boat, or even just its periscope, from many miles away, through the thickest fog or darkest night. The Germans, for a crucial period, had no way to detect these high-frequency signals. For them, a radar-equipped aircraft simply materialized out of the ether, already in a perfect attack position. This was a technological leap of monumental significance. It effectively blinded the U-boat while giving the Allies a new all-seeing eye. But this was only one piece of the puzzle. Finding a U-boat was one thing. Locating it precisely enough for a concerted attack in the vastness of the ocean was another. This is where a second, equally revolutionary system came into play: high-frequency direction finding, or HFDF, affectionately known as Huff-Duff. The German Wolfpack tactics, so effective in the early war, had a critical vulnerability. They required communication. U-boats had to radio their location and convoy sightings back to U-boat command in France. These were short, coded bursts, but they were a signal nonetheless. Huff-Duff was a system of radio receivers that could get an almost instantaneous bearing on any radio transmission. By equipping multiple ships in a convoy's escort screen with these sets, Allied commanders could perform real-time triangulation. The moment a U-boat radio operator transmitted his report, the Huff-Duff operators on several different ships would get a bearing. Where those lines on the map crossed, there was the U-boat. It turned the U-boat's essential communication network into their own death warrant. Every time they spoke, they gave away their position. This combination of passive detection through HF, and active hunting with centimetric radar created a layered defense that was incredibly difficult to penetrate. And powering this entire technological onslaught was the overwhelming force of American industrial production. The story of the Allied victory is also the story of the American shipyard. While Germany struggled to replace its U-boat losses, America was engaged in a shipbuilding program that still beggars belief. At the heart of this was the Liberty ship, a simple mass-produced cargo vessel. At the peak of production in Henry J. Kaiser's shipyards, a new Liberty ship was being launched, on average, every single day. By the end of the war, more than 2,700 of these vessels had been built. They were the targets, but their sheer numbers meant the U-boats could never sink them fast enough to make a strategic difference. It was a war of attrition Germany could not win. Even more crucial was the production of warships. The United States built over 150 aircraft carriers during the war, the majority of which were smaller, cheaper escort carriers or jeep carriers. These were often built on merchant ship hulls and were slow, but they could carry enough aircraft to provide continuous air cover for a convoy, effectively closing the mid-Atlantic gap forever. To put these numbers in perspective, the total number of escort vessels and long-range aircraft produced by the Allies in 1943 and 1944 dwarfed the entire number of U-boats Germany managed to build during the entire war. And critically, every piece of this Allied arsenal was standardized. A radar set built in a factory in Ohio would work perfectly on a British-built frigate. The ammunition was interchangeable. The tactics were uniform. This was not just manufacturing. It was the weaponization of an entire economic system. It was the principle that quantity, when guided by superior technology and a clear strategy, possesses a quality all its own. Now, let's examine the situation from the other side of the Atlantic. What was happening within Germany's naval industry? While the Type 7 U-boat was an outstanding design for its time, its effectiveness was being fatally undermined by a nation stretched to its breaking point. Germany had initiated a war it was not industrially equipped to sustain over a long period. By 1943, the cracks were showing everywhere. The advanced technologies required to keep the U-boats competitive, more advanced radar, better anti-aircraft defenses, new torpedo propulsion systems, required resources and specialized manufacturing facilities that were constantly being targeted by Allied bombing raids. Quality control began to suffer. New U-boats were sent to sea with faulty welds or improperly machined parts. The intricate network of suppliers was in chaos. A factory producing essential ball bearings in Schweinfurt could be flattened, and suddenly the production of dozens of critical components would grind to a halt. The result for the U-boat crews was a cascade of mechanical failures. A boat might be unable to dive quickly because of a faulty valve, a death sentence when an aircraft was bearing down. Torpedoes, particularly the early acoustic homing models, were notoriously unreliable, often detonating prematurely or failing to track their targets. Many U-boats were lost not to enemy action, but to catastrophic diving accidents or mechanical breakdowns in their own home waters, taking with them crews that Germany could not afford to lose. The fuel situation was becoming increasingly desperate. While Allied ships had access to vast reserves of oil from the Americas and the Middle East, Germany was reliant on limited European oil fields and increasingly on synthetic fuel production. These hydrogenation plants were a top priority for Allied bombers, and their systematic destruction created a persistent fuel crisis. U-boat patrols had to be shortened. Training exercises for new crews were curtailed to conserve diesel. This meant that by the latter half of the war, Germany was sending out beautifully designed submarines, crippled by production flaws and rushed assembly, manned by crews whose training had been tragically inadequate. This was the grim state of affairs for the U-Boot-Waffe in the spring of 1943. It is a testament to the immense bravery and skill of the German sailors that they continued to go to sea at all. But courage cannot fix a flawed torpedo detonator or conjure fuel out of thin air. So, when these two diametrically opposed systems, one of overwhelming abundance and technological synergy, the other of increasing scarcity and desperation, met in the decisive convoy battles of May 1943, the outcome was a foregone conclusion. The numbers from that month tell a story of almost unimaginable carnage. The Allies directed their convoys around known wolfpack concentrations using intelligence from ultra-code breaking, while actively hunting for U-boats with dedicated hunter-killer groups built around escort carriers. In the battles for convoy ONS-5 and SC-130, the U-boats faced a new reality. As they closed in, their radio transmissions were instantly pinpointed by Huff Duff. Escort ships raced to the bearings, forcing the U-boats to dive. Then, the hunter-killer groups would arrive. Long-range aircraft equipped with radar and lee lights would patrol relentlessly, day and night. The moment a U-boat surfaced, it was detected and attacked. If it remained submerged, the escort ships would hunt it with their improved ASTIC, or sonar, and pound it with depth charges and the new forward-throwing Hedgehog weapon, which fired a pattern of contact-fused mortars. There was no escape. The hunters had become the hunted. Major Bryce Goldsboro, an American civilian scientist who helped develop the radar systems, described the new tactical doctrine with chilling simplicity. He stated that the goal was not just to protect the convoy, but to make the very act of approaching a convoy suicidal for a U-boat. They were creating a zone of lethality, a moving fortress of electronic detection and overwhelming firepower. The difference in weaponry was becoming just as decisive. The depth charges dropped by Allied ships and planes were now more powerful and could be set to detonate at greater depths, crushing the more robust hulls of the newer U-boats. The sheer volume of fire was staggering. An escort group could saturate an area where a U-boat was suspected to be, creating a series of underwater concussions that would rupture pipes, shatter gauges, and extinguish the lights, leaving the crew in terrified darkness as the hull groaned under the immense pressure. The U-boat's own armament, the torpedo, was becoming less effective against the agile, zigzagging escorts. While German engineers worked feverishly on new weapons like acoustic homing torpedoes, their introduction was too little, too late, and they were plagued with their own reliability issues. It is one thing to have a deadly weapon. It is quite another to have the systematic means to deliver it and survive the attempt. The Allied system had both endurance and a knockout punch. By the end of Black May, Karl Dönitz, the head of the WWII, was forced to confront the horrific losses. 41 U-boats had been destroyed in that single month, a quarter of his entire frontline strength. Over 1,500 experienced sailors had been killed or captured. On May 24, 1943, he sent a signal to his boats, admitting defeat. The enemy has succeeded in gaining the upper hand in submarine defense. The losses in the short time have been too high. We must therefore economize our strength. The battle in the North Atlantic, the main theater, is for the time being to be broken off. That was just the beginning. The loss rates would continue to climb, turning service in the WWII from a dangerous occupation into a near-certain death sentence. Perhaps the most significant disparity between the two sides, however, was not in the steel or the electronics, but in the human beings at the heart of the conflict. This was not just a technological gap, it was a chasm in training and experience. The Allied sailor or airman arriving in the North Atlantic in 1943 was part of a highly sophisticated training pipeline. Aircrews practiced for hundreds of hours, using advanced simulators to master instrument flying and radar operation. Anti-submarine warfare schools in Britain and the United States used captured German equipment and detailed analysis of past battles to teach their sailors the latest tactics for hunting and killing U-boats. They were part of a system designed to create not just sailors and flyers, but expert practitioners of a highly specialized form of warfare. The German U-boat crewman he was facing was, through no fault of his own, often a young man thrown into one of the most complex and unforgiving machines ever devised. By 1943, Germany's veteran commanders, the aces who had terrorized the Atlantic in the early years, were almost all gone, killed, captured, or promoted to shore duties. Their replacements were young men rushed through a training program that had been systematically starved of fuel, resources, and time. Some new commanders went on their first war patrol with only a handful of practice dives under their belt. They had never experienced the terror of a sustained depth charge attack. They were learning tactics from a manual, not from a seasoned mentor. They were being asked to fight a coordinated, technologically superior enemy in the most hostile environment on Earth, with barely enough experience to operate their own vessel safely. It was a heartbreaking and utterly hopeless situation. Many historians have noted that it is this human factor, the sheer systemic difference in preparation, that is the most profound aspect of this story. This advantage permeated every element of the Allied effort. For an Allied aircrew flying a long-range patrol over the ocean, the mission was a calculated risk, but one that was mitigated by an extensive support network. They had accurate weather forecasting. They had reliable navigation aids. Their aircraft were robust and well-maintained. And crucially, they had a chance of survival if they went down. Air-sea rescue squadrons were on constant alert. The psychological reassurance of knowing that if an engine failed, a real effort would be made to find you was a powerful morale booster. It gave crews the confidence to push their aircraft and themselves to the very edge of their capabilities. The German U-boat sailor had no such safety net. If his submarine was critically damaged and forced to the surface, he faced the strafing guns of enemy aircraft. If the boat sank, his chances of survival in the frigid waters of the North Atlantic were practically zero. His emergency rations, if he was lucky enough to escape the sinking hull, were a cruel joke against the vast, indifferent ocean. The farewells given to U-boat crews as they left their pens in France were not formalities. They were understood by all to be, in all likelihood, final. They did not expect to return. Of the approximately 40,000 men who served in the WWII, nearly 30,000 never came home, the highest casualty rate of any branch of any military in the Second World War. This grim calculus was exacerbated by the physical toll of the missions. Weeks or months spent in a cramped, foul-smelling steel tube under constant stress, dealing with the perpetual damp and the nerve-shredding anxiety of the hunt. It was a supreme test of human endurance. Here again, Allied industrial philosophy made a life-or-death difference for their own personnel. The ships and aircraft of the late war were designed with an increasing focus on crew efficiency and survival. The cockpit of a B-24 Liberator was spacious compared to many other aircraft, with logical control layouts designed to reduce pilot fatigue on grueling 14-hour missions. The living quarters on a new destroyer escort, while Spartan, were a world away from the hot-bunking, oxygen-deprived misery of a submerged U-boat. An alert crew is an effective crew, and in anti-submarine warfare, alertness meant survival. The Type 7 U-boat, by contrast, was a product of a philosophy that prioritized offensive capability above all else, including the well-being of the crew. Life aboard was brutally uncomfortable. The air was thick with diesel fumes and the stench of unwashed bodies. A sailor might have to contort himself into an awkward position to operate a critical piece of machinery. It was a difficult boat to live in and a punishing boat to fight in. And it was unforgiving of the small mistakes that exhausted, terrified, and inexperienced young men were guaranteed to make. The Battle of the Atlantic was, in the final analysis, a war of logistics. It was a straightforward contest between America's limitless industrial output and Germany's constrained and blockaded economy. And nowhere was this disparity more clearly demonstrated than in the waters of the North Atlantic. Each successful Allied convoy that reached Britain was a logistical triumph. Hundreds of ships, carrying millions of tons of food, fuel, weapons, and soldiers. A continuous, unstoppable river of material flowed east across the ocean. A river sustained by a fleet of tankers and supply ships that were themselves the product of mass production. For Germany, the logistical situation was a slow-motion implosion. By 1944, there was so little fuel available that U-boat operations were severely restricted. Torpedoes were rationed. Entire flotillas were kept in port for lack of spare parts or trained crews. Mechanics had to resort to cannibalizing multiple damaged U-boats just to get a single one ready for sea. This was the unseen war. The war fought on production schedules, supply manifests, and fuel gauges. And it was a war Germany had definitively lost long before its final surrender. Even the weather, the U-boat's traditional ally, became another weapon in the Allied arsenal, though it extracted a heavy price from them as well. In the brutal winter storms, it was the larger, more stable Allied escort vessels that could continue to operate their radar and sonar effectively, while the smaller U-boats were tossed about mercilessly, their crews exhausted and unable to fight. It was a brutal reminder that this war was pushing men and machines to their absolute limits. The cumulative result of all these factors, the technological chasm, the industrial imbalance, the training gap, the logistical collapse, was the complete and utter neutralization of German submarine power and a devastating blow to the morale of the entire Kriegsmarine. Admiral Eberhard Gott, Dernitz's chief of operations, captured the sense of hopelessness that pervaded U-boat command. In a post-war reflection, he wrote, "The appearance of aircraft with this new location device, day and night, over our U-boats was a shattering blow. How can we conduct a war of attrition when our own weapon is being attrited at an unsustainable rate?" The sight of our loss charts in the summer of 1943 told us what our leaders were unwilling to publicly admit. The U-boat war was lost, and we were simply sending our best young men to their deaths. That was the ultimate achievement of the Allied anti-submarine campaign. It was not just the impressive number of U-boats sunk or the protection of the convoys. It was the psychological demolition of a weapon and a strategy that had once threatened to win the war. It was the tangible, undeniable proof, delivered by radar waves and depth charges in the middle of the ocean, that Germany's cause was doomed. By the time of the D-Day landings in June 1944, the U-boat threat was a shadow of its former self. The massive invasion fleet crossed the English Channel almost unmolested by submarines. Not because none were sent, but because those that were sent were ruthlessly hunted down and destroyed by an Allied anti-submarine screen that had achieved total mastery of the seas. The U-boats had been swept from the board. Today, only a handful of Type 7 U-boats survive, silent monuments in museums around the world. Meanwhile, the principles of the systems that defeated them, radar, sonar, signals intelligence, and integrated air and sea power, are the very foundation of modern naval warfare. They are a living, evolving testament to a time when Allied science and industry collaborated to solve a seemingly unsolvable problem. It is a profound legacy. And if this story of systematic ingenuity resonated with you, sharing it is the most effective way to ensure these lessons are not lost to time. The shock the German U-boat crews felt in 1943 was more than just tactical surprise. It was the dawning, horrifying realization that they were not just fighting ships and planes. They were fighting an integrated system, an entire coalition's philosophy of science, production, training, and innovation, all focused on their destruction. In the end, it was a war of cold, hard mathematics. And the defeat of the U-boat was the final, irrefutable proof. So, to distill it all down, the U-boat was not just outfought. It was the product of a system that was overwhelmed by a superior one, a system it simply could not match. And this systemic defeat delivered a critical blow to an empire that had already gambled its future on a short and decisive war.